Hello, everyone. Welcome to another episode of OpenObservability Talks. I'm Dotan Horvitz. I'm a developer advocate. And actually, I'm quite excited to say that we've reached an important milestone in the podcast. We've completed the full year of the podcast, 12 monthly episodes about open source, DevOps, and observability. And we had really amazing experts from the community on these episodes, really exciting. All the episodes, as you know, are available on all the popular apps. And if you're not aware of that, we're also streaming. We stream all the episodes live on YouTube and Twitch. So you're more than welcome to tune in on the live streams and type in your questions, your comments, and take part. It makes it much more fun, trust me, also for me. And also, we are more than happy to have more people from the community involved. So if you are interested, do check out the CFP on the website, openobservability.io, or just reach out over Twitter at OpenObserve or directly to me at Horvitz, Horovits, whichever way works for you. We'd be more than happy to have more people involved and also on feedback on the past year and what you expect to see on the coming season. So do stay tuned. And with that, let's go to today's episode. And today I'm actually quite excited about the topic. The topic is going to be about Kubernetes observability. What the challenges, we're going to talk about the challenges of these environments, the solutions, the technologies in general, and the eBPF in particular. We've discussed that in previous episodes briefly. Very exciting new technology that bears the promise of low code to zero code instrumentation to instrument and gain observability in these environments. For the guest, I have an expert about this. We have Natalie Serrino. Natalie is a founding engineer in Pixie Labs that has been acquired a few months ago by New Relic. So now part of the big corp and actually also part of an open source because Pixie has been contributed as an open source to the CNCF. It's been accepted just last week to the sandbox, CNCF sandbox. So a lot of excitement. Hello, Natalie. Good morning.
Good morning. Great to be here.
Great to have you. Great to have you. Sounds like you've been having quite some interesting few months recently with all the news.
We have, yeah. I mean, it was awesome working on Pixie and then having the chance to join New Relic and open source the entire project has been a wild ride and super awesome. And we're thrilled about the recent news that we've been accepted as a CNCF sandbox project.
Way to go. It's amazing contribution also to the CNCF community and the cloud native ecosystem in general. So we're definitely going to talk about Pixie and the open source. But maybe we can start by hearing a bit about yourself. You come from a background that is less typical. Usually we have people coming from heavy DevOps, SRE, and so on. Actually, what I like very much about your background is the data aspect, the data analytics part of it. Can you tell us a bit about your journey?
Yeah, for sure. So I technically started in hardware, but pretty early on in my career, I got really interested in data problems. And I joined this company called Trifacta when I was still, pretty early on in my career. And the cool thing about them was that they were solving a problem that I had always had, but didn't know there was a solution to, which was cleaning up and preparing data sets. Because a lot of times cleaning up the data set is the most effort. And we see that in the observability space as well, too, in a lot of cases. So that was kind of what got me into the data space and thinking about data problems. And I spent a few years in that domain before becoming really interested in the topic of observability, which coming from that data lens, I tend to see it a little bit like a data problem.
Yeah, actually, that's exactly how I look at it when I talk about observability. I think that one of the things that I emphasize many times is that essentially it's a data problem. It's having all the signals, all the telemetry, but being able to ask the questions that you want to know about your system is in essence what observability is about, at least for me. So it's really exciting to see someone coming from the data realm and looking at it in that prism. So today, actually, we're going to talk about Kubernetes observability. And I guess the first question that comes to mind is, What's so special about observability specifically in Kubernetes? Why is that any different?
Yeah, so I think that, there are a few things that make Kubernetes observability a little bit different. You start with a lot of the same challenges as normal observability. You want to know, are my machines overloaded? Is the CPU too high? Is the network, being maxed out? So you start with, similar sets of challenges, but then you layer on a couple more that are specific to Kubernetes. So one of them is debugging Kubernetes itself in the control plane. I'm sure I'm not the only one here who has misconfigured my Kubernetes cluster deployment and spent a while trying to figure out what the heck is going on here. So I think that that's, one Kubernetes specific challenge. I think another challenge is the, classic thing of microservices, because Kubernetes is set up to help people adopt a microservice architecture, which means that rather than a monolith that's, doing everything in one place, you have a lot more requests, a lot more stuff happening in a distributed way, which means that as you're looking at any one part of the system, it can be harder to understand the bigger picture. So I think that that is another challenge. And then the other thing I would highlight is that Kubernetes resources are inherently ephemeral. We have pods coming in and out of existence. The mentality of you want to treat your stuff more like cattle, not pets, where you can move it around and, not treat it too precious. And that is a really great thing when you're building a distributed architecture. But I think that when you're trying to hunt down a problem some user faced, it can be challenging from an observability perspective when these things may not exist anymore or have different names, and you can't necessarily easily find the source that it came from.
Yeah, that makes a lot of sense. And also there's obviously the Kubernetes specific control plane and all the Kubernetes specific metadata that people need to be able to enrich the signals with and need to correlate according to that. So sort of different dimensions if we talk about the data look of it, right?
Yeah, and I think also, there's challenges around security where people, may not want some of this very sensitive telemetry data to leave their cluster in certain cases. Kubernetes can, help provide a little bit of a firewall around, some of your application with its networking stuff. So that can be, an interesting aspect, and, just stuff like that. And as more and more developers take on some of this kind of traditional kind of ops stuff, those lines get blurred, I think that we also see a desire for more programmability of observability systems.
Yeah, I think this is the ability to query and programmatically get this information is becoming more and more essential in these systems, which brings us essentially to the way to handle that. I guess you mentioned microservices, and typically this brings about the question of instrumentation, and especially on the tracing side of things, where it can become quite heavy. So how do you view the current state of instrumentation, general manual instrumentation in particular, being the main path?
Yeah, so I think that we are still kind of early on in this journey. I would say the industry is still trying to kind of form the consensus on what some of the right practices are. And so it's an exciting time to be thinking about this type of thing. I mean, the major thing that, everyone kind of hears about at this point would be OpenTelemetry, where you use code to instrument your services, and you use maybe the OpenTelemetry collector to collect that information and, use that for analysis later. And I think that we're at Pixie really big fans of OpenTelemetry because it creates a data standard for the format of this information, which makes it a lot easier to correlate a bunch of stuff together. So I would say that, one of the main players right now, or main architectures, is to use code to instrument your services and probably follow the OpenTelemetry specification.
Yeah, although we've been discussing several times about OpenTelemetry in the podcast, I think I see at least OpenTelemetry is something between You mentioned the manual side, so you need an SDK, a language-specific SDK, obviously, and the Java one, the Python one, the .NET one, and then you instrument manually. But then again, I think, and I see that in the discussions on the relevant SIGs in the Open-telemetry. Now it's tags, they changed the name, but essentially that they put a lot of emphasis on enhancing also the automatic instrumentation. So they try and sort of identify the relevant libraries. I don't know, for Java, it could be Spring. For Python, it could be Django or something else. And then assuming that a large part of the audience uses these libraries, then they put the hooks there so that it saves a lot of the coding when you use these libraries. Is that something that you see as well?
Yeah, for sure. And I think that one of the great things about OpenTelemetry is that, based on the data standard, it doesn't really matter like how it was collected as long as it all comes out in that same standard. And so, whether you're getting the data in an automated way, or if you have said, hey, this is a part of my application I really want to pay attention to, so I'm going to put the effort to put this code in to collect that information, in either case, it can end up in the same spot. So I think that, we do see the language specific agents, like you're saying, where people instrument like common libraries and Node and things like that. Yeah. So that can definitely, be something that is, happening. And I think also people are interested in using service meshes for this problem as well, to basically say, hey, if I'm already running a service mesh, maybe I can, collect the traffic that service mesh is routing for me and use it in an observability context. Yeah.
Anyway, it's classic. You already have that sidecar and controlling all the traffic. So at the very least, you can have the ingress and egress sort of defining a scope that can be identified and reported on. Which reminds me, there was a very nice blog post that I saw about instrumentation with Istio. So maybe I'll share that at the end of this post as part of the news part. But how much is that? So auto instrumentation is like the holy grail. Everyone is looking for auto instrumentation. But beyond the buzzword of auto instrumentation, how automatic is it really? So, for example, you mentioned service meshes or agents. How close does it get? Because at least for me, example, the Istio one that I mentioned, you do see that you still need some level of coding. It's not entirely codeless. So how close do we get? Are we getting to real auto instrumentation with these current offerings? We're soon going to go to Pixie, of course, but even before that, with the ecosystem that we see, what's your feeling about that?
Yeah, so I think that they can be the right solution depending on your needs. So in the case of service meshes, that may not be the right architecture choice for everyone in their application. But for people who are using it, it can be a good way to capture your HTTP data. You'll still want to augment that with collection of, other kinds of information like system metrics and, maybe profiles of your application. But if you're, pretty much exclusively interested in that network traffic, that can be a good option, or you can augment it with other tools. I think with the language specific stuff, it's great as long as the thing that you want is instrumented.
Yeah, makes sense. Which brings us to, I guess, the new and exciting kid on the block, eBPF. Not so new, actually, but you'll give us the brief history of that, but now picking up extremely well. And I guess this is a technology on the kernel level, on the Linux level, that brings a new direction of taking instrumentation that is much less coding, no code, because you do that on the kernel level. Can you tell us a bit about that?
Yeah, for sure. eBPF, or I might also refer to it as BPF, kind of can use both terms, is a really awesome, relatively new technology to the Linux kernel. So the premise behind BPF is that you can basically, this may not be how everybody explains it, but I almost think about it as the ability to add hooks to your kernel. So if you want to say, like, every time you open a file, call my little function that I've defined. And, it allows you to basically specify probes that get to run anytime the operating system does something. And this can occur in the kernel space or in the user space. So it's really powerful. And, in some ways, it's so powerful that we're still just scratching the surface of what we can do with it, but it's been really utilized in the networking sphere. You can create custom firewalls that say like, hey, drop everything that isn't this type of traffic that I'm looking for, and make your systems more secure. Or you can do something to say like, every time you write to a file, like let me know, or start a process. Like it's very, very functional and very powerful. And so we at Pixie got pretty excited about applying that to the context of observability.
In fact, I think it actually, historically, it started from the networking context and the networking implementation. Then the extension to the BPF was more taking it toward the direction of system calls and other areas, if I'm not mistaken, right?
Right. And, I think we have to give a shout out to Brendan Gregg, who really helped popularize it. His work in that space has really helped everybody who uses it today. So, he has been a major player in that.
Yeah, that's true. And now with this extension, I think the context comes to mind with really observability and the types of information. Maybe can you help us understand what kinds of information can we collect out of this sort of instrumentation?
Yeah, so a whole lot. You can, in the context of observability, you can collect, full body request traces. So you make a MySQL request, you make an HTTP request, the gRPC stream. You can leverage BPF to get, capture entire requests, of any network or of any protocol. So that one is really exciting because it can work across like many different types of traffic. You can also collect statistics about resource utilization. You can collect CPU, or how many bytes am I reading? How many bytes am I sending on the network?
Is that something that is calculated on the fly, or that has to be like pre-calculated and just collect the pre-made metric? How does it work?
How does it work to collect the?
Yeah, when you have performance metrics, is that something that you need to put in the logic to calculate the the on the fly, the sliding window, whatever that, or is that something that you need to have the hook there to calculate it for you and you just pick it up straightforward?
Yeah, so at Pixie, we collect it as a counter, and then our downstream queries will process it and turn it into percents and things like that.
Okay, gotcha. So you have counters pre-made that you can plug into.
Yeah, for sure. And then also another really cool one is, using it to collect like profiles of what your application is doing, where it's spending its time, which function is eating up the most of the resources.
Nice. That's a lot of discussion about profiling as part of the new. I think actually we had an episode that we talked about profiling as the next signal in observability, or the something that should be looked into as part of the overall observability. So it's actually an interesting direction. Maybe I should have a dedicated episode just on that, because it's really exciting. And another question that I encounter often when I talk about eBPF is about the security, because people say, okay, you take a piece of bytecode, you inject it into my kernel. That sounds not the safest thing. How do you see the security aspect of that?
Yeah, so I think that that's something that the community has put a lot of thought and effort into, because it is a very powerful thing that you can do with your kernel. So we have to make sure that, sure, these may be Linux superpowers, but they need to be used for good, not evil, right? So I think that one thing that's really important to know about BPF is that it imposes like very strict requirements on the probe or the hook that you want to execute. So you can't just write any arbitrary code. It does a very, very thorough security pass on the probes that you're trying to install and make sure that they're not doing anything untoward. So I would say that that's one really important thing to keep in mind, is that you can't just write anything arbitrary. There's some strict rules about it.
Is that like, I don't know, one of the examples that I've at least encountered is like if your code does like an infinite loop or something like that, that will start eating up the cycles. But what kinds of checks can be done in a static way to identify risks?
Right. Yeah, I think a loop is a really good example of that. So it actually causes us in our, BPF side of things to have to think really carefully about how to structure some of these collectors.
Yeah, sounds good. I'm trying to think about so obviously it's a Linux kernel thing, so it's Linux environments. Is there any suitability for other types of environments, or what kind of, where is that applicable in terms of variety?
Yeah, so I think that Linux is definitely the main one, right? Like there's some talk. I think there's a recent project, eBPF for Windows, which is a cool development. But for now, we think of it as a pretty Linux focused thing. And from what we've seen, observability, like that covers pretty large part of what we're interested in solving for people.
Yeah. I'm just checking to see, I think starting Linux 4.13. I'm just checking for myself to see what where the support is getting. So I guess everything beyond that version, but still only Linux. At least I think the Windows starts supporting that.
Yeah.
And the next question that again I encounter quite often, not just for eBPF but in general for instrumentation, is the aspect of performance. So many people ask me, okay, you put some extra code that listens and generates some, I don't know, spans or metrics or logs or whatever. How much overhead does it incur? So what do you know about the performance aspect?
Yeah, it's a really good question, especially because in observability, half the time you deploy an agent and it's on your production system and it's using like half your resources. It's like, what the heck is going on here? So I think that, obviously people's production systems are very sensitive. We want to have a very low overhead, and BPF, depending on what you do, I mean, it can have a variable overhead just depending on the probes you insert and where you insert them. But I would say that, in the context that Pixie is using BPF, we see the overhead as less than 5%, and it is usually less than 2%. So we have a really strong commitment to trying to keep the overhead as low as possible because of the importance of the systems that we run on.
Makes sense. I think in general, from what I know about eBPF, it's important to note that it's a compiled code. It's like a just-in-time compiler so that ultimately the compilation is takes place in advance, and then you get the bytecode already there. So maybe just to reassure some of the audience that is less familiar with that it is a compiled bytecode that is executed, right?
Mm-hmm. Yeah, and if you're using it for observability, you can use it to monitor itself, see how much how much it's taking up. We actually use our own tool all the time to debug resource consumption stuff. So
yeah, sounds good. I see actually we have some questions from the audience around that. Let's see the question here from the audience. What's the baseline for the consumption? What's the percentage of what?
Yeah, so we typically think about CPU for that, but we also want to make sure that memory is, not being overly impacted as well. I think CPU is like normally the one that is the one to watch.
Sounds good. And we have another question that relates to something that we talked about before, about other types of instrumentation. Eric is asking, how is it different from Istio or Istio sidecar or Envoy in that respect?
Yeah, so if you're thinking about sidecars, they're basically going in between, your application and the thing sending it a request, and they're directing that traffic, monitoring that traffic, looking at that traffic. And so that is kind of a layer in between what's happening, and it usually runs as a separate pod or container. So the difference between that and BPF-based observability is that in BPF, you're actually going right to the source of where the event is happening in your application. And you're extending the Linux kernel to capture those events based on the types of probes that you're registering using BPF. So rather than having a separate component receive the traffic, look at it, and do something, you actually just go right to where the traffic is happening. And the implication of that is that you don't need a separate component and you don't need to do anything other than add these probes.
Yeah, and again, I think beyond the scope that you mentioned, I think the variety of events that you can collect, right? With the sidecar, it's mainly they sit on the path for
Right.
the, again, as you said, the ingress and egress of the operations. I think you get to finer granularity and different types of data on the eBPF level. Huh? No?
Right. Yeah, like mentioned, like CPU profiles, things like that. You can use all those to,
Yeah. Sounds good. I would maybe also say something that maybe for me it resembles more the types of language-specific agents in the respect that very much similar to these frameworks, like I don't know, hooking onto Spring or other middleware framework that the language-specific code runs on. The typical way that these agents work is that they plug into existing hooks or interceptors or things like that, and in the worst case they do like bytecode manipulation. But most of them just take the existing hooks and just integrate with them, which is very, very similar to what the eBPF does, obviously in the higher level of the middleware. So maybe if I would look for the closer equivalent, it would be more of the language-specific agents.
Yeah, although in those cases, hardware metrics or other kinds of like system metrics, I think that when you're tapping in at the OS layer, you can get access to both the application level stuff as well as the system level stuff.
Yeah, it makes a lot of sense, and that brings us to Pixie. First of all, again, congrats for getting accepted to the CNCF as a sandbox project. That's really exciting. So I guess Pixie's mission is exactly to use eBPF to overcome all these challenges that we talked about before. So tell us a bit about that. Let's start with how did Pixie start? What was the mission statement? What the idea? Where the idea came from?
Yeah, so I think that when the founders were starting Pixie, a lot of it really came out of the fact that they wanted to build the observability tool that they always wanted to have themselves. And I think that that's where a lot of projects like this come from. It's like, we are the users, we have these needs, and this is what we want it to look like. So I think that, I had worked with one of the co-founders, Zane, at Trifacta, and I think that when we were there, we did find troubleshooting and debugging production systems to be a big challenge, and a much bigger challenge than debugging your local developer environment. So I think that they were thinking, like, how can we make debugging this production system more like debugging a local developer environment? And I think that when thinking of the company, there were kind of like three major things that, Pixie was looking at as problems to solve in this space. The first problem is the difficulty of collecting telemetry data. There are a lot of code changes required to do so today in most cases. Lots of different tools collecting different kinds of data that have to be like synthesized together in the same place. And you tend to see a lot of challenges around just getting the data in the first place. And to an outsider, it doesn't sound necessarily like it would be that hard, but like a lot of things, it actually is the more you get into it. So we found that like collecting the data, it was a really big issue. Another issue that we saw was that, a lot of architectures have moved towards a more cloud-based architecture. And so what that meant in the observability space was that people were collecting large amounts of telemetry data and trying to send it to a remote cloud where their tool was hosted. And I think that, there are upsides to that, but the downside is that the volume of data can be a really big burden on network, especially in a production system. And so you end up either sampling the data or overloading your resources to export it all out there. And it can also introduce, some challenges with security if you're not comfortable with that sensitive data leaving your cluster, for example. So that was another problem. And then the last problem we kind of alluded to earlier, which is the challenge of making observability systems more programmable. How can we, embed these systems into more automated workflows? And in a lot of cases, we were hoping for it to be more like writing code that could run anywhere rather than having to be in kind of like a walled system that is hard to kind of expose the interfaces of. So I think those were some of the challenges that they were thinking about, and we can talk about some of the solutions to that.
Yeah, so essentially, and so eBPF was something that you had in mind from the get-go, or is that something that you discovered as a means to an end afterward?
Yeah, I think that was something that was, a core part of the approach early on, because it was relatively new in Linux terms, but extremely promising in what it had been proved out to be able to do. So, that was basically one of the main answers to the first problem, which is how can we give people, especially Kubernetes users where there's so much application traffic between the various components, access to a very, very deep and immediate baseline observability into their system. It doesn't mean they'll never add code to instrument their system. In fact, like, we believe in progressive instrumentation, where it's a combination of automatic and explicit instrumentation in your system. But right out of the gate, I want to be seeing which systems are talking to which systems, who's using the most resources, where are they spending that time, and what's my service map, like who's involved. And we believe that should be something that is available to people at very little effort right out of the gate.
Sounds good. And by the way, is that just around the tracing, or is that something that also pertains to other types of telemetry data?
Oh yeah, it's all types. So tracing is like obviously a big one, but you can also immediately get access to resource utilization and things like application profiles, when you deploy Pixie.
Great. So do you want to tell us a bit about how it works, how you in Pixie utilize eBPF, and what's the functionality that you offer?
Yeah, for sure. So, kind of just like to address some of those like three challenges that the founders were looking at, we answered kind of the first one, which is use BPF to provide baseline visibility across all of this different kinds of data that we just mentioned. Another important thing to know about our system is that it's built for Kubernetes. It's meant to run on the Kubernetes cluster and collect and embed Kubernetes metadata into everything that it does. Mm-hmm. So when you're reasoning about your system, you're reasoning in terms of pods and services and clusters. That is a really core part of the way it works. So
the dimensions we said before that are very unique to Kubernetes environment.
Right. Yeah. And I think one thing that's kind of exciting about Pixie is that it runs entirely, all the data processing happens entirely on the customer cluster, and the data is stored there, which we found people really, resonate with for, privacy concerns about that data, because you collect this very deep observability information and it's so useful for troubleshooting systems, but we also keep it where it was collected so that, there's not a concern about it being stored elsewhere. So that provides those security or privacy benefits, but it also provides lots of performance benefits because it reduces the overhead of running our system. And then the other thing with Pixie is that, it's built to be fully programmable. We have a Pythonic query language because we didn't want to reinvent the wheel there. And you can execute arbitrary queries using our API. So we've seen people use Slack bots with custom queries that can alert them if something's up. So I think that those are kind of like three things that address it. But at a high level, what I would say is Pixie, you deploy it to your Kubernetes cluster in a few commands. It automatically provides you with UIs that show you the state of your cluster and ability to drill down into particular nodes and pods and see kind of a conglomeration of application information like full body requests or request statistics, but also some of the resource utilization stuff we've been mentioning, and merging those two data types together in one place.
Nice. You also have all sorts of machine learning capabilities to help reduce the noise and do some effective clustering, no?
Yeah, we do. And this is something that is pretty exciting. And I think that, for a long time, a lot of people have been thinking about, applying ML to observability. And I think that our philosophy for that is rather than replace the human in the loop and try to use AI to solve the whole problem for them, what we really want to do is rapidly speed up their iteration and make the human in the loop a lot faster than before. And one of the ways that we do that today is by using machine learning to cluster different types of requests and traffic together. So users can look at clusters and see their behavior. And I actually used that feature the other day myself when troubleshooting a production thing where if you looked at the overall request statistics, it looked fine, but then when you dug into a particular cluster, you could quickly see that there was a problem there. So that's something that we're really excited about.
I think the ability to segment also, you have one endpoint, but then you need to segment according to different flows and different tags or something like that. And only then do you discover that this is the problematic one. The ability to do this sort of segmentation is something very powerful.
Yeah, I mean, even something like a URL parameter can be a difficult thing for a lot of tools where you want to just bucket based on a wildcard, but today that can be a surprising challenge. So that we felt that was a clear win to apply ML to.
Yeah, sounds good. I see also we have another question from the audience. So the question is it possible to know what's being transferred through HTTPS and encrypted communications?
Yeah, so I think if you're saying is it possible to use eBPF to know that? Definitely. I think that as for Pixie, I think that is something that we currently kind of treat HTTP traffic as HTTP traffic, but if that was something of interest to people, then that could be something that we would look at more.
I think it's an important note in general about BPF, because the fact that it's in the kernel level, it can actually access, I don't know how Pixie addresses it, but in general, the technology as a technology allows to access the code before the encryption or after the decryption stages, right?
Right. Yeah, and so even if it is encrypted traffic, we have the ability to read that.
Yeah. Makes sense. And and you said that you also essentially allow for the querying and programmability. So you have a sort of an API that programmers can actually script the parts and create sorts of automations on top of that, right?
Yeah, I mean, we really wanted, observability, workflows that we had to be code that you commit to GitHub. We wanted it to just be a normal part of the developer workflow like anything else, rather than, tribal knowledge and a few martyrs' heads that come out whenever there's a production incident. And so it was really important to us that we had a really flexible and fully featured query language to empower people to use this data in the ways that were most useful to them. So we provide a lot of functionality right out of the gate with pre-built scripts, but it was also important to us to support custom scripts that the users write. And so, in the kind of spirit of having these scripts be more like code that developers write every day, we wanted to, instead of making up a new programming language or something like that, we wanted to actually try to follow existing standard APIs. And so what we decided to do was, first of all, our query language follows Python syntax. So you can use it in editor with Python styling and just, it looks just like Python. And for the querying and manipulation of data, we were always really big fans of the Pandas project. And for people who aren't familiar with it, it's probably the best open source tool for, manipulating data sets for analysis. And all of the things that it does were the same types of things that we needed to do with Pixie. So we said, okay, well, let's, rather than reinvent the wheel, let's just follow what they do and follow their API. And, we've heard from our users that they really like that, especially if they're already, users of that project, because it just reduces the barrier to entry and they can just write code like any other code.
Cool. That sounds like a much easier start. So for now, essentially, now that you're part of CNCF, do you have any plans? Obviously, Kubernetes is a very central goal that you have, in your instrumentation. Is there any other additional integration that you expect to have within the CNCF ecosystem, maybe in general in the cloud native sphere that you're looking into as part of joining the CNCF? Yeah,
I mean, I think there's a lot of really amazing projects in the CNCF, and by joining it, we feel it gives us an opportunity to collaborate with those projects even more than before. And I think that when you are, when you're a startup, integrations with other tools are important, but when you're an open source project, it's critical, because open source projects need to work with other open source projects and play nicely together, because that's just a really important part of the ecosystem. So we're really excited to expand our OpenTelemetry integration capabilities, and also build integrations with tools like Prometheus. So we're really excited to do more of that. And the fact that Kubernetes is a CNCF project made it a really clear place for us to try to end up as well.
Nice. So and by the way, I assume the choice of CNCF was a natural for you, given that you're looking into the Kubernetes ecosystem and that. So
yeah, for sure. I mean, when you look at the projects there's a lot of clear synergy, to use a business term.
Yeah.
What we're doing and what they're doing. And so we're really excited to be among those amazing projects.
Why go in a foundation path to begin with? You could open source without doing that. Just curious why you went down this path.
Yeah, it's a really good question. So I think that the community that it provides is obviously a really big part, and we also see it as a commitment to our audience and our users to say that we're going to remain open source, we're going to be Apache 2.0, and we're going to stay that way because we're a CNCF project, and that's our commitment to maintaining those standards going forward as a project.
I think that's something that echoes well, especially in light of some other open sources today that are governed by vendors, and then suddenly things shift and licenses are being changed, and this is something that raises concern amongst the community members. So seeing this sort of commitment, I think echoes very well. So at least on my end, I think it's a good move to show the goal that you're taking here. So if you're looking at what's lying ahead beyond now being part of New Relic and joining the CNCF and open sourcing Pixie, what's up in the roadmap for you guys?
Yeah, so we have a roadmap page on our docs, so we can send that out or put that in the thing. But to kind of summarize, I think that we want to expand in a few ways on what we've been doing. We want to support more environments. Today there are certain environments that we don't support yet, like Docker for desktop and things like that. So we want to expand the environments that we support is one thing. We want to expand the type of data we collect. Like, while Pixie collects a really rich set of observability data, with eBPF, you're really just scratching the surface because of the huge capabilities that it has. So we want to collect even more types of data. And so something like log data, for example, is something that we'll be looking at in the future. We want to expand the ML capabilities that we have. I mean, I alluded to certain things like clustering based on different types of requests, but we think that we're just in the very early days of those kinds of assistive AI UX experiences, and so we want to really expand that, and we want to also improve the Kubernetes support that we have and make even more resource types available to query and look at their history of the events that took place involving those resources in Pixie. So I think that's another one that we want to do.
Nice. By the way, for our listeners and our audience on the live stream, if you have any more questions as we're drawing near to the end of the conversation, do feel free to type them in now, and we'll try to squeeze them in. I have maybe one question more on the personal note of your experience. So you've been through this amazing journey from being a founding engineer in a startup all the way through to an acquisition, and then yet again joining open sourcing the project, then joining a foundation. All of these are major things. I'm not sure that many engineers undergo all of these in one row. But so, how do you summarize this journey, your personal journey, and maybe some useful tips that you can share with us about to experience some of these?
Yeah, for sure. So, I mean, I think that it's been a crazy year for us. We launched the product, we got acquired by New Relic, we open sourced the project in its entirety, and then we, were accepted into CNCF. And I think that each one of those times is a different phase of what you're doing. And so, every single new phase, it feels like a reinvention, and the needs of our open source users versus the needs of our users when we were, a paid product in the past, like, those are very different. And so what I would say, like, my best advice is just like to, embrace the new challenges that you see with each phase, and try to really like listen to people in the community and like, what are they doing? What are they trying to do? I think it's easy to get a little lost in the weeds of like the specific project you're working on, but it's really important to like always see the big picture and see how the work you're doing can be extended to address some of those problems. I guess that's a little bit generic, but trying to be as general as possible.
No, it's fair enough. I think also from experience, for example, now I'm part of the OpenSearch new open source, and I think some of the things that you see in organizations that are not accustomed to or are coming new to the open source realm is some cultural changes also in terms of the engineering works and the product road mapping. Suddenly you need to have everything exposed. Mm-hmm. You can't have any back channels closing in, although it may be very efficient in the short term, but then again, you need to loop in the community. You need to do it in collaboration with the community. You need to get consensus about things. You need to have very clear visibility into what's coming ahead. Is that something you've experienced?
Yeah, for sure. It's a huge mindset shift because, on one hand, there may be a tendency when you go open source to be afraid to like open everything up. Like, if I made a dumb commit at some point, like that's all public, right? Yeah. And so, it can be a little scary to open up not just the history of what you've done and what you're doing, but also roadmaps for the future, because sometimes the roadmaps can change. And so it can be scary to, make all this information public because it opens you up to, more people giving their opinion about whether or not it's correct. But I think that, even though that can create some challenges, what you gain in return is trust from the people that you're serving with the project. And so even if they don't agree with every decision, they know that you're going to be open with them about what you're doing and why the whole way. And I think that it's one of those, multi-round games, if you know what I mean, where, in the beginning it can be a little scary, but what you get in the long run by being open is definitely worth it.
I can't agree more. I'm really sorry that we're out of time, because I could ask you many more questions about that and others, but I want to thank you very much, Natalie, for joining us, and thank you for sharing all this information. Fascinating topic.
Thank you so much for having me. It was a pleasure.
Thank you very much. And with that, let's move on to the breaking news section of our podcast. The episode, each episode, I'm trying to get some interesting bits or publications or updates that I would like to share. The first one that I'd like to share that's actually directly relevant to the podcast today, the topic today is a blog post by the Netflix engineering team. Let me share that for the ones that are on the YouTube. Just a second. Get that one. Here we go. So what you can see here, that's a blog post on how Netflix used the eBPF flow logs at scale for network insights. It's actually quite fascinating to see. They talk about using eBPF trace points to capture TCP flows at near real time. In terms of performance, we talked about performance on a conversation with Natalie. Netflix specifically talked about less than 1% of CPU and memory on an instance, highly performant. So I think it's a fascinating case study, and obviously at Netflix scale, it's something that is something that definitely we can learn from. It's not a hack or a POC by any means. So it's an interesting post that I've encountered that I wanted to share. Another one that's relevant to that is about I mentioned that instrumenting microservices with Istio for distributed tracing. So again, I recommended. That's relevant to what we talked about before. Just to understand what it takes, assuming Istio is the most popular, currently the most popular service mesh out there. So probably quite relevant for people who are looking to see how to start with that. It's a very thorough blog post. And one of the things that I liked about it is that it covers sort of two ways, let's put it, of instrumenting. One, first of all, two languages, one example with Go and another example with Java. And also in terms of the approach. So one uses the open tracing APIs to propagate the trace data, and another one by manually forwarding HTTP headers to propagate trace data. So you get quite a varied example with code snippets and with examples that you can follow to see how to do that. So another something that I thought might be useful. Another thing that is relevant to last month's episode, I hosted here Kyle from AWS to discuss OpenSearch, just as it was about to release the release candidate. So shortly after the episode, the release candidate indeed came out, and you can read about that on a blog post on the community side. So really exciting, and actually in the coming month, in July, the GA is expected to come out as well. Again, yet to be seen. It's an open source, as you know, and the pre-GA, but that's at least the current plan. So you can get all the information about that on this blog post. And congrats to OpenSearch, and look forward to the GA finally after this interesting journey that it has gone through. Let me see what else we have here. Something else that's interesting that I saw is a survey just from yesterday, in fact. Let me share that. It's a survey by the CNCF together with the FinOps. Sorry. So the title should be already intriguing. Kubernetes, a black hole of unpredictable spend, according to a new report. So I had to read this article after this. So CNCF, together with the FinOps Foundation, as I said, did quite a survey. They had, although only 195 respondents, but they say it was interesting, clear signals. I think that the most important thing that I saw is first, that the vast majority of respondents either do not monitor Kubernetes spending at all, which is 24%, or they rely on monthly estimates, 44%, which was quite astonishing, because people actually don't know how much it costs them to operate. And amongst those who did monitor, it was interesting to see that less than 25% of those who surveyed said that they could actually predict how much they'd spend on Kubernetes to within 5% of actual cost. And it climbed to 60% when they were asked if they could predict within 10% of real cost. So it shows that there are lots of operational challenges with Kubernetes that we got to talk in previous episodes, but the financial, the FinOps side of things is also something we don't talk enough about, but still people need to, I guess we as a community and the industry need to, I guess, mature up a bit more also about the way that we are able to measure and understand the cost aspects of managing and running Kubernetes. Let me see. Maybe we have time for one last bit. So this one is something that was published in the new stack, and also regarding tracing. titled "Why Logs Aren't Enough to Debug Your Microservices" by Michael Haberman. By the way, I had the pleasure of hosting Michael here at the podcast, talking about tracing and about using it in pre-production scenarios. So you're more than welcome to check out this episode in the OpenObservability Talks for more information by Michael Haberman. But this specific one I found very, very extensive and interesting, to show that at least in modern environments, in microservices ecosystem and so on, you can't rely only on logs, and the value of traces becomes not a nice to have, but actual must have for many of the flows that you encounter. So really recommend this post as well. I'll post the link also as part of the episode. So I think that's as much as I can spend on the breaking news part for this episode. We'll keep some for next time. But definitely I would like to thank again Natalie for joining me for a fascinating episode. And I would like to thank you for joining and listening on this episode. I hope you found it useful. You can find, as I said, all the episodes on your favorite podcast apps. It's also available on YouTube. And you can have a look at the website, openobservability.io. By the way, we revamped, we had a facelift for the website, so it's much more intuitive now. So check it out, openobservability.io. If you have any topics that you would like to submit, we have a CFP open there on the website. Just submit your topic. We'd be more than happy to have more members of the community taking part of this. So go ahead, and you can also find everything around it with the Twitter at OpenObserve, or you can reach out to me at Horowitz. We'd be more than happy to get feedback on the summary of the 1 year of the episode, ideas for the podcast, ideas for the next season, and anything else. Just let us know. You have all the information here. I'm Dotan Horowitz, and thank you very much for listening, and see you next month on the next episode. Thank you.